Next one is chemical bonding. And molecular structure. Chemical bonding and molecular structure. Now, what do you mean by bonding? Before going to define the bonding, what do you mean by chemical reactions? That I mentioned in the previous class. Chemical reaction and why chemical reactions that occurs in nature. A chemical process that is involved in the breaking down of the old covalent chemical bonds or old chemical bonds with the simultaneous formation of the new chemical bond or chemical bonds is called chemical reaction. During the breaking of the old chemical bonds, energy is required while during the formation of the new chemical bond, energy is released. Therefore, during the formation of the chemical bond, energy is always released. Now, why chemical reactions occurs in nature? Because atoms combine to give molecules. Atoms are unstable, molecules are more stable. This implies that atoms during the chemical reaction, they continues to gain electrons or continues to lose electrons until they acquires the nearest noble gas configuration. That is why in order to attain the stable state or the nearest noble gas configuration, atoms combines to give molecules. Atoms are unstable, molecules are more stable. What is chemical reaction? What is chemical reaction? What is chemical reaction? Why chemical reactions occurs in nature? Why chemical reactions occur in nature? Why chemical reactions occurs in nature? In order to acquire least energy and maximum stability. Maximum stability. In order to acquire least energy and maximum stability. Atoms are unstable. Atoms are unstable. While molecules are more stable. Atoms are unstable while molecules are more stable. Because the energy possessed by an atom is more, energy possessed by an atom is more. Energy possessed by molecule is less. 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 Energy possessed by an atom is more means atoms are unstable. Energy possessed by molecule is less. Molecules are more stable. Molecules are more stable. Therefore, least energy and maximum stability, these are the criteria to undergo chemical reactions. criteria to undergo chemical reactions. Now, Lewis dot structure. Lewis dot structure. Suppose oxygen, when you write the electronic configuration, atomic number 8, its electronic configuration 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. During the chemical reaction, whereas the 6 electrons will be there, 6 electrons. Six electrons will be there, and oxygen atom, and for hydrogen 1 electron, for this hydrogen 1 electron. Therefore, here it is an octet state. Here this is an octet state. Hydrogen that forms octet, it forms octet state. 1, 2, 3, 4, 5, 6, 7, 8 numbers of the electrons are there. It is an octet state. For hydrogen 2 electrons are there. That is an octet state. For this hydrogen 2 electrons are there. It is an octet state. Therefore, hydrogen has ability to give off an electron or shares an electron, 1 number, this hydrogen 1 number, and this oxygen 1 electron, 1 electron. Therefore, here the valency of this oxygen is 2 because it has ability to react with that of the 2 electrons, and hydrogen 1 because only 1 electron is participating, that is only exclusively 1 electron, this hydrogen 1 electron. This is about the Lewis dot structure. Lewis dot structure. In case of the ammonia, whereas nitrogen of the ammonia, that nitrogen has 7 electrons. Its electronic configuration 1s2, 2s2, 2p3 configuration. 1s2, 2s2, 2p3 configuration. And nitrogen having this is 2s atomic orbital electrons, 3p atomic orbital electron, these 2p atomic orbital electrons. Now, hydrogen having 1 electron, and this hydrogen having 1 electron, and here 1, 2, 3, 4, 5. Here these 3 electrons are there. Here hydrogen 1 electron. What about the total number of the electrons? 1, 2, 3, 4, 5, 6, 7, 8. Count the number of the electrons here. How many electrons will be there? 8 electrons. Therefore, it forms one covalent chemical bond. Therefore, 3 covalent chemical bonds are formed. Therefore, that shares 3 electrons. Nitrogen having 5 electrons. Therefore, 5 electrons of nitrogen. They shares 3 electrons of this hydrogen. The total number of the electrons will be 8 electrons on ammonia. Here also 6 electrons on oxygen and 2 electrons from hydrogen, total 8 electrons in water. This is higher energy level. Inner atomic orbital electrons are also there, but these are higher energy level electrons. In nitrogen, 2s atomic orbital electrons are not involved. 2 atomic orbital electrons. 2 atomic orbital electrons. 2 atomic orbital electrons are not involved in chemical reaction. Not involved in chemical reaction, and they have affinity with that of the proton, and they have affinity with the protons. Affinity with the protons. Proton acceptors are called proton acceptors. Proton acceptors are called bases. By knowing the dot structure, Lewis dot structure, we can have, therefore it is called as a Lewis base. Therefore it is called as a Lewis base. Ammonia is a Lewis base. You know that when there are electron efficient species are there, electron efficient species they act as a bases. Electron deficient species they act as an acids. Electron efficient species are bases. Electron deficient species are acids. Electron deficient species are acids. And PCl3 and PCl5. There is a phosphorus, atomic number 15. Its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3. Outer shell has 5 numbers of the electrons. These are and Cl 1 number and Cl 1 number and Cl 1 number. See 5 electrons here, 1, 2, 3 electrons are here. Now it is an octet state. This is 8 electrons now. 8 electrons corresponds to octet. Now they have ability to form one covalent chemical bond. It has ability to form one covalent chemical bond. It has ability to form one covalent chemical bond. Therefore 3 covalent chemical bonds are formed. 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 Okay. PCl5 again. This is phosphorus. See the number of the electrons. Here 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 numbers of the electrons. 1, 2, 3, 4 and 5. The total number of electrons are 10. Therefore, 5 covalent chemical bonds are formed. Five covalent chemical bonds are formed here. This is about the Lewis dot structure. Lewis dot structure. But in case of the boron trichloride, boron trichloride, boron trichloride, boron trichloride, and boron trifluoride, aluminum trichloride, aluminum trichloride. Whereas in this case, they are electron deficient species. Electron deficient. Electron deficient species. Therefore, such type of molecules are called Lewis acids. Now, my concept is here is, say, some of the molecules like that of sodium chloride, potassium chloride, magnesium chloride, or calcium nitrate, or sulfate, whatever it may be, some cases of these metallic salts, they are soluble in water, whereas some they are insoluble in water, and some they possess high melting point, some they possess low melting point, and some they show shining property, and ice that floats on the surface of the water, ice possesses that anomalous behavior at 4 degrees Celsius temperature. Water has a higher boiling point or abnormal boiling point. Now, what is this due to? See, I read something on the board that is a chemical bonding and molecular structure. See, these letters are visible to us. Why? There is an affinity between the chalk molecules and the board. Some type of the attractive forces are there between the board and chalk molecules. This affinity or attractive force is called one type of the chemical bonding. When you replace this chalk by means of the gaseous molecules like hydrogen or oxygen or nitrogen, then we won't write something on the board. Therefore, we can call these metals, they are unable to form the chemical bond. You are writing in your notebook by using pencil or pen. See, the dye molecules, which is nothing but your ink molecules, they have affinity on your paper. Means some valence electrons are there between the ink molecules and that of the paper molecules. And hence, because of the residual forces or attractive forces are there, that is the main trigger for the chemical reactions. Now, residual valencies or residual forces are there. This helps in the chemical bond formation. Now, why sodium chloride possesses high melting point, whereas some other molecules like organic molecules, they possess low melting point. Because ionic bond compounds, they have high melting point, and covalent bond compounds, they possess low melting point. Low melting point. What do you mean by chemical bond? Chemical bond is the type of the attractive force or repulsive force where it holds the atoms together in the molecule of the substance. Whereas two or more atoms or cluster of atoms, when they combine, then they lead to the formation of the molecules. Therefore, bond is attractive force between the atoms, not necessarily it is the repulsive force also between the atoms. Why? Because whereas the electrons are there in the higher energy level of first atom and nucleus is there for the first atom, therefore the nucleus of the first atom, it has affinity with that of the electrons of the neighboring atom. That is why nuclear force of attraction will be more, and hence the chemical bonds are formed. Is it clear? Chemical bonds are classified into different classes: strong bonds and weak bonds. Strong bond and weak bond. In a strong bond, molecules are stable. In strong bond, it is stable. In weak bond, more amount of the energy is released. Suppose this is delta H is equal to minus, but energy release will be more. Energy released will be more. Energy released will be less. Energy released will be less. Strong bonds means ionic bond, covalent bond, coordinate bond or dative bond, and metallic bond. Metallic bond. Weak bonds are van der Waals forces of attraction, van der Waals forces of attraction and hydrogen bond. Van der Waals forces of attraction and hydrogen bond. Is it clear? This is about the various bonds that are present in the molecules of the substance. We can explain this nature of the bonds, ionic or covalent or coordinate or metallic bond, and van der Waals forces of attraction or hydrogen bond one by one in the next class. Thank you.